third metamorphic jump and coke microstructure. In recent years, people have paid increasing attention to the microstructure of coke. However, a large part of whether the coke's microstructure is good or bad originates from the coal itself. What kind of coal can improve the microstructure of coke? Here, I need to talk about the coal's third metamorphic jump, which occurs at the stage where reflectance is around 1.8. From this stage onwards, the coal's molecular arrangement becomes oriented, and optical anisotropy significantly increases. If we utilize this well, we can form a better anisotropic microstructure of coke. The value of coal at this stage lies in its ability to modify the coke's microstructure. 30 years ago, I co-founded a joint venture coking plant in China with a subsidiary of a major South Korean steelmaker. At that time, our main goal was to produce foundry coke. The chairman was an expert who had previously produced foundry coke in Korea. I served as the general manager of this coking plant. We faced several demanding specifications from parent company for this high-end foundry coke, including porosity, shatter strength, size, and hot strength. When considering these parameters, we conducted research and experiments. Its focus and core idea was to fully utilize the characteristic of optical anisotropy of coal after the third metamorphic jump. Then, we would blending coal types that could match the coal at this stage. Besides requiring a certain quantity of plastic mass and melting softening range from other types of coal, we focused on the coking process technology. How to make this caking component coal and our primary target coal form carbon bond connections on the surface of this highly metamorphosed coal. And with the plastic mass during the coking process in the coke oven, this would make them integrate into one body after forming coke. On one hand, this continuously optimized the coke structure. On the other hand, it increased its lumpiness. This met the strength requirements for coke. Under the guidance of this approach, within just a few months, we used this method to meet all the requirements across various indicators. At that time, in our domestic foundry coke sector, our costs were actually the lowest. We didn't use a lot of high-quality coal, yet our coke quality, lump size, and density were the highest. Later, the services I provided at multiple foundry coke production enterprises were all based on the research findings from this plant.